Hello, ladies and gentlemen. Um, let's get down to chapter 2. Chapter 2 is about overview of C, problem solving and program design in C. In this chapter, we're going to go through some example of code and so that you guys can see what's going on. So the objective of this chapter is to allow you to become familiar with the general form of a C program and the basic element in a program. It also helps you to appreciate the importance of writing comment in a program. How do you write comment in C? And then how um, this this chapter can also help you to understand the use of data type and the difference between the data type int, which is integer, double, float, and character. And this chapter will also help you to declare variables. And then we're going to see all those writing assignment, evaluate arithmetic expression and how to write them in C. And then learn how to read data value into a program and to display a result. Understand how to write format string for data entry and display. And then how to use redirection to enable the use of file for input output and to understand the difference between syntax error, runtime error, and logic error, and how to avoid them and to correct them, because some are, syntax error are pretty much easy, because if there is error in the syntax, your program is not going to compile. So those are easy to detect. Runtime error is when you compile your code and then you run it, then there may be some error into the data entry. For instance, if you have a value you divide by 0, can't divide anything by 0. Therefore, when you start entering the data, you can have some problem. Logic errors, those are errors which are difficult because your program works fine, everything is clean cut, you have the result. The problem is there may be some error in your logic, and the only way to detect those errors is to test and have somebody test your program. That's why in a lot of companies you have software tester that test to make sure that the program is behaving the way the program should be behaved. So those are the most difficult logic error, because your program looks fine, but there may be a problem. Okay, so C program is a high-level programming language, but it's really close to the machine. A lot of operating systems have been written in C. Okay, it was developed in 1972 by Dennis Ritchie at AT&T and Bell Labs. It's designed as language to write the Unix operating system, and you all are familiar with the Unix operating system. It's one of the main popular operating system are the Unix and Windows, and then you have others. Okay, then it's basically look like everyday English, and it's very popular. A lot of other language came from C, C++, C#, Java, and so on. Now, when you write your program, there is something called preprocessor. The preprocessor is a system program that modifies a C program prior to its compilation. We're gonna see some example. Okay, this means that before the program compile, the program check that line before it compile. Okay, it means that it's almost the first line out there. We're gonna see a library. It's a collection of useful function and symbols that may be accessed by a program, because there is already a lot of function written so that you won't have to invent the wheel from scratch. That's the beauty with programming. you can use those and then try to come up with your own stuff. Okay. Each library has a standard header file whose name ends with a symbol H, like standard input output. So when you do this, those functions are imported so that you can use it, like print and so on. But we're gonna see. So this is an example here. Okay. So preprocessor, a C program line begin with pound sign. Okay. It's kind of provide an instruction to the preprocessors. It means that on top of when your program, before it compile, it need to import this one here, this library standard input output header, so that inside this there are a lot of functions you can use, and we will see that. And then you can also define, for instance, this is kilometer per mile and 1.609. What this means is this variable, you can pretty much change this variable with 1.609. So you kind of define. So what's going to happen is that when your program is compiling, the program will look for any variable like this and change it with these things, with this number. The beauty is that if you want to change this value, there is only one place you can change, here. You don't have to change it in all program, in all code. So that's the beauty. When you have those variables which are fixed, you can define them here, so that the compiler just look at it and say, okay, let me replace this variable with this in all the line, and then compile. So that's the beauty of having this. It kind of save you a lot of time. So here, have a constant macro, a name that is replaced by a particular constant value. That's what they're saying here. Okay. So this is a constant. It means that, hey, you can say this variable is this. So it's constant. It doesn't change. Okay. You can call it constant macro. Okay. Drinking water. So it's called constant macro. Okay. So in one of your programs, when you're doing your program, and if you want to convert mile into kilometer, then you need this constant here. Okay. So because maybe this may change, you never know. So if you're going to be using this one in many lines, you just have to define it here, and then if you change it in the future, you only change it one time here. Okay, so you define it here, and then in your code, when you write this variable and those two variables, and then you have a constant here. And then comments are written like this. You have star in between. There are also other type of making comment. We will see that, but this is a comment. Okay, you see this guy, it's a comment. It's between star and this. Okay, and it's always good to write comments so that you know what you're doing. Now let's look at this code here. What this code is doing, this program convert mile to kilometers. It means that if the code is given mile, is gonna output kilometers. Now, what do? You have the preprocessors, those pound. So you have it include. It means that import the library, and which is standard input output header file. So when you do this one here, automatically you can use those two functions here. Print F, it means that print things on the screen. scanf is to take input from customer, input. So it means that you can use those. You don't have to write the function. It's already done for you. But to use them here, you have to write this guy. And then because you want a constant, you're gonna be using it everywhere. So all you need to do is just to write this constant, and this is the value here. Okay. And now this is the body of your code. You see you have the main function. You open bracket and you close here, and this is the main function. And those are reserved words. You shouldn't be using them as variable when you're writing. So those are reserved words here, okay? Because you don't want to confuse the program. When it's trying to compile, it's looking at double and your double. So try to avoid using reserved word, okay? It is integer. This is double, or you can call it float. And then those are variable here, okay? You can run this on one line, or you can write in two lines, it's fine. So just saying distance in mile, and this is equivalent distance in kilometer. You define the variable you're going to be using, and you have to define the variable. If you don't define the variable, you're going to get some error. Whatever you're using, you have to define them. If you're using mile and kilometers, you have to define them, and the type here is type double, okay? So, and you have main here, okay? So the int here is the return function, which is basically integer, because it returns 0 if your program compile very well, okay? So this is the main function, and it's void because it doesn't take anything here. And so you have double, and then you print this one saying enter the distance small. So basically this one will be print on the screen here, enter the distance in small. Now when you enter the distance in mile, so that's become input. So you're using these identifiers here. So scanf. Now when depend on which compiler you're using, if you're going to be using Microsoft Visual Studio, it will give you some error here because the compiler in Visual Studio is using scanf_s because that one is more secure, but it really doesn't matter. The compiler will tell you which one to use, okay? So this one, we will see that later, okay? This one is just, when you input your mile here, it's gonna save it. This is a placeholder. We'll see that it's hold the place. This is a float, okay? And now the mile here, when you enter your mile, so this variable here just point to the address of the location of miles. That's what this ampersand miles means, that it's a pointer to the address of mile, because when you enter your mile, it needs to be stored. We saw this in chapter 1. It needs to be stored somewhere. So this one, just specify where is the address location of where you're gonna store your input. That's what this means. So when you do scanf, you always use ampersand. It means it's a pointer to the address location. And then once you have your kilometers here, which is the variable you define here, like I say, everything you have to define before using it. So you already know this one here, which is 1.60, and then you multiply by mile because you enter mile here, and this gives you the value of kilometer. Now you can print it on the screen, and that's what this line is saying. Once you have a value here, and this is the placeholder, this will print literally, and this will be replaced with this one here. Okay, so this is the absolute, this is the value. Okay, it's not a pointer anymore because we're using printf. It means that you're gonna print the value here straight. You're not trying to store it anywhere. Now this one is just a placeholder into this line here. Okay, so, and you can call them, so reserve words and punctuation here also. This means new line. Okay, this means new line. Okay, and you always end your code or your line with, with this punctuation. Okay, so that's basically this gives you an overview of the code. So here you have a processor. This always comes first, and then you have your main function here. Int means the return type is 0 here when the program compile very well, and then you define the variable you're gonna be using, and the type here is double. So, and you print this on the screen. Okay, so we will try to, let's apply this one here. Okay, so let's see. For instance, this program I can write it. If I open, I already have it here. Okay, so you can see it here. So you have it, the same code here. So you have when you write it in Visual Studio, I already show you how to write a code in Visual Studio. So there is a video out there, you can watch it to be able to write this one. Okay, the name of this one is chapter 1, exercise 1. I just, so you need to watch that video, how to write a C code like this one in Visual Studio 2019 community. Okay, so you have this one, it's the same thing here, and you can see here I say scan S. Okay, because if you remove this guy here, so there will be some, and then you can try to build. Okay, you build your solution. It's gonna, you see, scan this function of variable be unsafe. Okay, consider using this one instead. Now if you want to disable, you have to write this one here in property here. Okay, you can write this part in property so that you can disable this this message, so that you can be able to use this guy here. Now, but if you don't do that, then you will have to use _s. And if you rebuild this one here, then everything will be fine. Okay, and then if you want to run it, then you go to your control F5. If you go to your control F5 here, you can see, so this is how things work. You see, when you run it, the program say, okay, I'm gonna read this, the header file, I'm gonna take this and then compile it, and then you see the exe, that's the one. If you send it to somebody, they run it and they can do this one here. So this is the output. So how things work here. The computer comes here and then it enter print here. It says, oh, I have entered the distance is mile. So I'm just write print enter the distance in mile. So it's waiting for you to enter something because the next line is an input. So if you type maybe 12, so it's going to take the 12 and put it in the location. Then it's going to come here and put 12 multiplied by 1.6, and then it goes to kilometer, kms, and then when the program comes here, it's going to print this one here. So it's going to print that equal this one. So if we do this, you put enter, you see that equal is because that equal, and then it put the kilometer here. So float. So that's what I mean. You can define how many decimal you want, but here it says print everything. So it's gonna print 319 point this one, and that's basically how your code here works. Okay, so this is so this gives you an overview of a C program code doing mile to kilometer conversion program. That's the one in your book. Okay, so and you can escape here, press any key to close. You can press any key to close this one here, and that's the code here. Okay, you can minimize, you can do the same things with your online compiler. I have it here. So this is the online compiler. I show you how to run a C program in online compiler. So it's here, the same code. The only difference is, you know, the compiler is okay. You don't have to write underscore s here. Okay, you can write your code here. You can just dump it here, and then you click the green, you know, run, and then when you run it, automatically you see it below. Enter the distance. You can enter whatever you want to enter, and 12, and then it gives you everything that's equal to this guy here, because they already have a compiler behind. If you run it, it will build the solution and then run it. So that's what, and that's, this one is the online compilers. Okay, so let me go back to the lecture notes. So that's what this one's here. Okay, so this, every C program has a main function. You know, you have the main function here. So this line mark the beginning of the main function, like I told you, and then you have declaration. So those are the part of the program that tell the compiler the name of memory cell in a program. Okay, and then executable statements. Those are program lines that are converted to machine language instruction and executed by the computer. So, and then you have the reserved word, you know, such as return 0. So, you know, this means that if everything works fine, the compiler will say, okay, return 0 means that, you know, it compiled very well. So when we talk about reserved words, those are special words in C. C use them. Those have specific meaning. You shouldn't be using those words as variable for your own program. And then you have a standard identifier printf, like I told you. To be able to use the printf, you have to, you know, import the standard input library. And so it just print this one here on the screen. That's it. Okay, and then user defined identifier, this name memory cells that hold data and programs, and to name operations that we define. So an identifier must consist only of letter, digit, and underscore. Okay, an identifier cannot begin with a digit, and a C reserved word cannot be used as an identifier. Okay, an identifier defined in a C standard library should not be redefined. Okay, so that's okay, and so that's what is here. So those are special symbols here. This is multiplication. This one is not your mathematical equal. Okay, there is a difference between this equal in math and this equal in computer science. When you see one equal like this is an assignment. It means I take this one here and give it to kilometer. If you wanna equal, if you want to use the mathematical equal, it has to be 2 equal here. So that's where you test in if statement. We will see that later. Okay, and those are your punctuations special, and those are standard identifier from the C. And then those are your variable here, mile, and those are your reserve word. Okay, and then those are the comments here. So variable name is, I mean, a variable is a name associated with a memory cell whose value can change. It means that you define a variable, okay? And then a variable, you have variable declaration. So statement that communicate to the compiler the name of variable in the program and the kind of memory, the kind of information stored in each variable. So you pretty much define the variable, and the compiler need to know what variable you're going to be using in your program. So here you have those two variables. Here you have hours, and the type of the hours is integer, and then you have miles, and the type of mile is double. Okay, so basically this tells the compiler the type of data stored in a particular variable. So this means that the type is integer and this is double here. And then, so the data type you have integer, they are the same in a lot of languages, C, C++, C#, Java, Python, and all those stuff. Sometimes there's a little bit of different, but they're always, the same. So integer is a whole number, like 4, 3, 5, 93, and so on, okay? There is no decimal point here. Double, that's where you have real number, okay? 3.14 and so on. And then character is those character, okay? It means that it's not an integer, it's a character, unless you change the type. So you can define a character in single quotation like this, okay? And then the int can be a binary, type int format binary number, and then double format you have a sign, exponent, and mantissa. We're gonna see this later, so don't worry about this if it's a little bit complicated for you. Just the type double, okay? Nobody's gonna ask you all these things, mantissa, exponent, sign, but these are things, if you are interested, you can find it. Okay, so, and how do you execute a program? You follow the declaration in a function you use to write code of the algorithm and its refinements, and then you translate the code into a machine language by the compiler, and then the computer execute the machine language version. So those are kind of the statements you do. Okay, so this is an example of memory before and after execution of a program. So here you have machine language mile to kilometer conversion program. So first of all, you have to define, assign memory location to the variable you just create. So you have two variables here, miles and kilometer, and then you put data in it when you start running your program. So you say, oh, mile is 10, then kilometer is 16. After you execute your program, then you run it, then customers start putting those data here. So those are the assignment statements. So like I told you, this equal just means assign this one to this variable, okay? It's not your mathematical equality. The mathematical equality is 2 equal here. This is an assignment. It means I assign this to this variable, okay? So store the value of this in this variable. And so this one is almost, the same things here. So before assignment, so you need to compute, okay? So you have a kilometer per mile, and when you have the mile, you have a content here. So you do the multiplication, and then the value you store in kilometer, because you already know the location of this variable, so that you have a place to put it. Otherwise, if you don't have a place, where you're going to put it? So that's why when you don't define this one here, and then you try to run, it's going to give you an error. It doesn't know where to put these things. Everything has to be defined before you start plugging things in it, okay? That's one of the main elements in C and C# and C++. You have to define the variable you're going to be using so that you can store things in it, okay? So this is before assignment and after assignment. And this is an assignment, the same thing. So assignment is not the same as an algebraic equation, like I told you, okay? So this one here is assigned to this one here. So it means that if you have a sum and then you add something to the sum, you assign it back to the sum. It means that it's gonna, overwrite the value here before, so that it can continue increasing, okay? So, and that's the same things here. So if the sum was 100 and then you add 10, then the new sum is 110, and then you can continue doing these things here, okay? So, and then you have the input operations. Those are the instructions that copy data from an input device into memory. And then output, you display the information, okay? So input output function, a C function that perform an input or output operation, okay? And then you have a function called, calling or activating a function. Okay, those are things, it's not hard. Now the printf, this is a special function in C. It's already done for you. You don't need to design this function. Is already done. All you need is to use it. You just need to know how to use it, and that's how it's used, okay? We already talked a lot about this line. This is a placeholder, and then the type is float double. So, and then you have kilometer. This is the variable, and this is the placeholder. The value of this will come here, and then this is the new line, okay? So this is the function name. This is the format here, and then this is a placeholder, okay? Placeholder, this guy here, and this guy is just the variable, okay? Print list. In a call to print list, the variable expression whose value are displayed. So because you want to display the content of this one, so you put a placeholder here with this look like a percentage. And this is an overview of placeholder in formats, okay? This guy is C means character, print F, scan F. And so D is not double. A lot of people think that double, it means it's decimal integer, okay? So it means that you wanna, is a placeholder for a variable of type integer. This is how you write it. And this one is double, okay? Float. If you use printf, and print and scanf, use lf, okay? Okay, so and that's the way you write your scanf here. So you have your percentage lf, and this one should be ampersand. There is a mistake here. So this is ampersand here, because this one here, when you do this, this one here is a pointer to this one here. Okay, so let me say ampersand. It should be something like this guy. Yes. And then I'm back. So it's like this, okay? So you have only one variable here. So whatever the customer will enter is gonna go to the address location and store it. So this one already has an address location of the variable mal, and then it's put the content in it. So when it's character, the same things here. You got 3 characters here. You put CCC, and that's it. So scanf. So when you enter 30.5, automatically, because this one already defined the address location of mal here, there's already a space set up in memory. You just, when you write, it just goes here. Okay. The same thing when you look at character, you have Bob, B-O-B. Okay, this is B-O-B here. And okay, the return statement just means that if your program run well, 0 is returned. The value 0 is optional. Okay, just indicate that your program executed without an error. That's the whole point. So what is the general form of a C program? We saw we have a preprocessor directive. So where you define, you get your standard input output so that you can use the print and scan. And then you have your main function, and then you have a declaration, and then you have an executable statement. And then use space consists, carefully, okay, so that your program is nice design. So it improve readability. So one is required between consecutive word in a program, okay. And then also it's always good to use comment in your code, okay. It's kind of enhance readability. So arithmetic operator, you have those guys you can use, run like in math. So this is the addition. 5 plus 2 is 7. So if it's, if the type is integer here, if the type is double, then 7.0. Subtraction is the same things here. Multiplication is the same thing. 5 times 2 is 10. 5 times 0, this is if you define in decimal. This is division. If you divide 5.0 divided by 2.0 is 2.5. That's why you have to be careful. If you want to see the decimal value, you have to make sure that you put 0.0 here. Otherwise, if you divide 5 by 2, it's going to give you 2. It's not going to give you a decimal value. So this is a lot of error a lot of students make, thinking that by dividing 5 by 2, they're going to get 2.5. It's not. You have to tell the computer that, hey, my 5 here is not an integer, it's a decimal. Then the result will be a decimal here. Now, this one is remainder is in all programming language. So it means that when you divide 5 by 2, the remainder is 1. Okay. So divide 5 by 2 is 2, and then the left is 1. Okay. So you can have mixed type expression, mixed type assignment, and then you can have typecast if you want to convert an expression to a different type. Okay. If you want to convert a integer to a decimal and so on. So you can use those mixed type expressions here. Now the unary operator, okay, so it's just an operator with one operand, okay, you get plus, minus, okay. So x equal minus y. So binary operator, an operator with two operands, okay. So you have x equal y plus z. Okay, so and now what is the rule? Well, you have to be careful. Operator precedence rule. Okay, so the unary plus then minus first. Next, you have multiplication, and division and remainder. And then lastly, you have binary plus minus. But I always tell students it's good to use bracket so that you kind of decide what should be the rule instead of letting the computer decide about the rules. So you have right associativity and left associativity. Okay, unary operator in the same sub-expression and at the same precedent level are evaluated right to left. And then this one is the left associativity, binary operator in the same sub-expression and at the same precedent level are evaluated left to right. Okay, anyway, let's see. So this is an application of all those blah 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 English. Okay, so you have area equal pi time radius. So what do? You can do this one, pi time radius. You get the result here. You take the result and then you time radius here, and then this give you your area. Okay, you start the left. The same thing here, step by step. You have this one, you take this one, you get the result, and then you do this one. Okay, this is just to show you. I mean, this is how things done. Now, that's where, I mean, I like to have things very clear. It's always good to put parentheses so that basically you kind of force the computer to follow your rules. So what you're saying is do the stuff in parentheses so that there is no debate. Okay, so the computer will do this one here, get the result here, do this one, get the result, and divide both. Okay, so that's what is here. Okay, you do this guy here. So this is much clearer. You pretty much know what the computer is doing. Okay, or something like this. Okay, you do those parentheses, and then you do multiplication because this one comes before addition, and then you can do both. So that's what is here. For instance, z minus this part here, you do what the part in parentheses now because you got a plus here. This one comes first, so you do b divided by 2, and then you get this one here, and then you do the parentheses, and then you do z minus this part here, and then you do the multiplication here, and then you do the addition here. Okay, so well, this is just show you what is done first. Okay, and then numerical inaccuracies, so those are error due to coding a real number as a finite number. Okay, so you can have some cancellation error, and then you have arithmetic underflow. So it's an error in which a very small computational result is represented as 0. And overflow is an error that is an attempt to represent a computational result that is too large. Okay, this is just an application of supermassive coin value programs, a program. I'm gonna go through it quickly, guys. Okay, so this one here, you're trying to determine the value of a collection of coins. This is your program here. You see you have include standard input output. You always put this one here, and we don't have some constant here. Okay, fine. So you have your main function, and then you have your return type, which is int, because your return is 0 here. And then those are how you define your variable, because you have to define those before using it. That's what I told you. So you got two variables here as character type, and then you have penny, nickel, dime, quarter, dollar, change, total dollars. Those are integer, okay? So you define them here and you comment. That's what the comment is here. So that's pretty much. And then what you're doing, you get and display the customer's initial. When you type the customer's initial, you say print. Type in your 3 initial and press return. So what's gonna happen? You type your 3 initial. So you're gonna be typing 3. So you have to define them in scanf here. So you have a first, middle, and last. And when you type them, automatically the computer will print those and ask you, please enter your quant's information, first, middle, and last. Okay. And once you do that, so what's going to happen here is you have you print those on the screen. Number of quants, you put the number of quants is dollar, the number of quarter, the number of dime, the number of nickel, the number of penny, and compute. It's good to run this. Just try to copy this code and run it, okay? And compute the total value in cent, and then you compute it. And then you find the value in total change. That's what is here, and then you display, and that's the display here, okay? And this is how things work here. When you type in your 3 initial GRH, automatically it says that, okay, GRH, because your GRH here, because when you type it here, automatically the value is here. So what's gonna happen, because you already defined those here, so you print it. So that's where it's a GRH, because it takes those values here, put them here, and then print. So basically it already knows the variable first, middle, and last. You define them here. So it's already know it. It just print it on the screen, and then it put this question here. Please enter your quant's information, 214, blah, 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 and then you do this. So basically try to run this and you should find it's pretty much easy. Okay. And then formatting numbers in program output, you have a width. Those are the number of columns used to display a value. And then you have an interactive mode that, when you write, you see the result right there. It doesn't save, okay? It's a mode of program execution in which the user responds to prompt, okay? Batch mode is when it's a mode of program execution in which the program scan is data from a previously prepared data file. So you have a data file when you bring it, okay? But here you use the keyboard and everything is done immediately. So this is an example here, batch version of mile to kilometers. So you have here, you define things here, and then you have your function here, you have your variable here, and then you scan mile here. So get and equal the distance in mile. So the distance in mile is, you have 2 decimal here. You see this guy here, and then you convert this guy here, and then you display, okay? So when you print the distance in mile is this guy here is 112, that's equal to 180.21 kilometer. Just run this code and see how it works. The best way is to run it. Okay, so let me see. And those are just IDE. I mean, it allow you to develop your code. Okay, like Visual Studio Community 2019 is an IDE. You have Eclipse. You have all those intelligent platforms you can put. Okay, now there are something called common programming error. So there are different type of error. Okay, when you talk about debugging, that's you want to check your error and remove them. Okay, I told you a little bit about this syntax error. Is basically a grammatical error in the rule. So this is easy. You can detect this one easily. Okay, and if you try to compile, it's not going to compile because there is error. And then usually there is some dot, some red things moving around your code. It means that there is a problem. So this is easily, you know, uh, detectable. You can clean it up. Runtime error, you're trying to perform an invalid operation here, like dividing something by 0. Okay, so when you compile your code, it's fine, but when you run it and then you put some data, then you may see the problem. So the logic error, those kind of an incorrect algorithm. It means that this is difficult because you kind of maybe put the wrong formula and the computer things will compile, but somebody had to test, so that's why you need to test your code. Okay, and those are some type of error here. Okay, so semicolon at the end of the previous source line. So because you didn't add a semicolon, and then your identifier mile, you didn't define mile here, so it gives you those error. So the same things here, and okay, and then unexpected end of file encounter in the comments. So yeah, so those are error you can find. This is a runtime errors, means that you're trying to divide something by 0. That's the whole point here. Because when you do second and first, because you define second and first as integer, then you're gonna this one will compile fine, no problem. Now when you start running it, that's where the problem is, because you are saying the first is 14 and the second is 3. So you divide 3 by 14 here is going to give you 0. Now 0 is going to come here. And then you trying to divide 14 by 0. That's not going to fly. That's where you have error here. Divide by 0 at line 272. It's not. So those are the logical error you can see. And then this is a revised start of main for supermarket coins value. So they kind of refine this program. So you enter the current year and press enter. The year will come here because the year is a decimal integer here. And then you type your free initial. Okay, I mean you can run this program and see. Okay, and wrap up. Every C program has preprocessor, directive, and a main function. The main function contains variable, okay, declaration and executable statement. C's data type enable the compiler to determine how to store a value in memory. So if it's an integer, or is it a character, or is it a double? And then it also tries to see what operator can be performed on that value. Okay, this was a quick overview of the C program, and I show you how to write a code in Visual Studio 2019 Community, and also using the online browser, so you can try those. Okay, and thank you very much.